You know that feeling, right? You're on a plane, landing at night, you look out the window and see this incredible, complex pattern of lights stretching out below. It honestly looks like a city of jewels, almost magical. But what if I told you none of that is random? That it's not just for decoration? Every single one of those lights is part of a silent, universal language. And today, we're going to learn how to read it.
See, every light out there is part of this incredibly sophisticated system. It's a silent conversation between the ground and the cockpit, guiding a massive, multi-ton aircraft safely back down to Earth. This right here is one of the most critical safety features in all of modern aviation. It's what turns total darkness into a clearly marked path home.
So that's the big question, isn't it? What is all this stuff actually saying? Well, from miles out, these lights start feeding the pilot crucial data. We're talking location, angle, distance. It's a visual code that every single pilot, anywhere in the world, is trained to read in an instant. And now, you're about to learn it too.
All right, so this whole conversation begins long before the wheels are anywhere near the pavement. The first big challenge for a pilot is just finding the runway in a sea of darkness and getting lined up perfectly. That's where the approach systems come in. They act like a brilliant funnel in the sky.
This is step one. When a pilot is switching from flying by instruments to actually looking out the window, the ALS, or approach lighting system, is that first beautiful, reassuring sign. It's this massive array of super high-intensity lights that stretches out from the runway, basically creating an unmissable path to follow.
Okay, so you're lined up. But now for the next critical question. Are you descending at the right angle? Come in too steep, you'll slam into the runway. Too shallow, and you might not even make it. This is where the PAPI system becomes a pilot's absolute best friend. It's just a simple set of lights, usually off to the left of the runway, that tells you exactly where you are vertically.
So, how does this magic work? Well, the PAPI uses this really clever system of lenses that shows either a red or a white light depending on your angle. If you see 4 white lights, you're way too high. 4 red lights, you are dangerously low. The sweet spot, that perfect 3-degree glide path every pilot is aiming for, is 2 white and 2 red. It's simple, immediate, and it's a constant visual check.
Now, before PAPI became the standard, there was an older system called VASI. And pilots came up with this unforgettable, if slightly dramatic mnemonic to remember how to read it. Red over white, you're all right. Red over red, you're dead. I mean, it doesn't get much clearer than that, right? And it just perfectly captures the life-or-death importance of getting this approach angle exactly right.
So what's the big difference between the old and the new? Well, it all comes down to precision. The older VASI system was good, but it really only told you 3 things. You're high, you're low, or you're on path. PAPI, with its single row of lights, gives you a much more detailed 5-step reading, from a little high all the way to dangerously low. And that's exactly why it's the standard you'll find at most airports today.
Okay, so you followed the approach lights, you've nailed that perfect glide path with the PAPI, and now you are just seconds from touchdown. The language of the lights is about to change again. Now we're shifting from guidance to the runway to guidance on the runway itself. The very first thing you're going to cross is this unmistakable line of green lights. This is the runway threshold. Think of it as the official starting line. It's a giant green light telling the pilot, okay, the safe, usable landing surface starts right here. You are cleared to land.
Once you're past that green starting line, your whole world is suddenly defined by these 2 bright parallel lines of white lights. These are the runway edge lights. They are basically the guardrails, showing you the left and right boundaries and making sure you stay right in the middle, especially when the weather's bad. But of course, a runway doesn't go on forever. So to give pilots a heads up, for the last 2,000 feet, those white edge lights suddenly turn yellow. This is the caution zone. It's a clear signal that says, hey, you're running out of asphalt, time to slow this thing down. And at the very end, a solid bar of red lights. That's it, the absolute finish line.
And on top of all that, a lot of big runways have these centerline lights that act like a high-speed countdown clock. They start out as all white. Then, for the last 900 meters, that's over half a mile, they start alternating between red and white. And for the final 300 meters, they all turn solid red. It's an incredibly smart way to tell a pilot exactly how much room they have left.
So the plane is safely on the ground, it's slowing down, the most intense part is over, but you're not at the gate just yet. Now the pilot has to navigate what is basically the airport's road system, a complex maze of taxiways.
And this is a really serious challenge. An airport at night can be a super confusing place, and making a wrong turn onto an active runway, well, that's one of the most dangerous mistakes a pilot can make.
So the language of light has to be absolutely crystal clear. No room for confusion.
So let's do a quick recap of the colors we saw on the runway, right? Green meant go or start. White was the main path. Yellow was caution. And red meant stop or end. The system keeps this same basic logic, but it introduces one brand new color just for taxiways.
And that color is blue. This is just a brilliant piece of design. Blue is used for one reason. It looks totally different from the red, green, and white of the runway. There is zero ambiguity. Blue means you're on a taxiway. White means you're on a runway. It's a simple, powerful distinction that keeps everyone safe and prevents pilots from getting lost.
And you know, the most incredible part of all of this? This isn't just a clever system they use at one or two airports. This is a global standard. It's a quiet testament to how countries all over the world cooperate to keep us safe in the skies. Think about it. A pilot trained in Australia can land a plane in London or Tokyo at midnight in the pouring rain and read the exact same visual language. This standardization is what makes our global air travel system one of the safest forms of transportation ever created. It's truly amazing.
And this isn't just for the huge international airports either. In Australia alone, there are over 260 airports and aerodromes, from the massive hubs down to tiny country airstrips that all rely on these very same systems. It's this vast, invisible network, all speaking the same language of light to make sure every single flight ends safely.
So here's my challenge to you. The next time you're on a night flight and you're looking out that window as you come in for a landing, I hope you see something different. You won't just see a pretty pattern of lights anymore. You'll see a conversation. You'll spot the green threshold, the white edges. Maybe you'll even catch those two red, two white PAPI lights that guided you in. You'll be reading the language of the runway.